Good morning, everyone. Welcome to CMP 210, Optimized Compute for Cost and Capacity. My name is Chris Foote. I'm a senior GTM specialist for the compute team, and we help customers cost optimize. So we have a lot to cover today, and the first thing we'll cover on our agenda is how this is a compute platform for virtually every workload. You have a lot of different instance types and flexibility, and we're going to cover how to select the right Amazon EC2 instance type for you. And to make those selections, we're going to guide you through a suite of tools to help you choose the best instances for your workload. And then we'll go into how to optimize across price, capacity, and performance, and optimize across those things. And last, we'll conclude. So if we go all the way back to the beginning, back in 2006, when we launched EC2, we only offered one instance size, and it was the M1. It only came with one vCPU and 1.7 gigs of memory, and it allowed for an on-demand purchase model. Customers could pay for what they use. They could quickly scale up and scale down as they needed and as their workload required. And this was a game changer, just because until EC2, the only option was for customers to build their own data center, manage the hardware with long-term commitments. It was a pretty significant improvement for our customers. But if we consider that 90% of the product roadmap is influenced by direct customer feedback, what we heard from customers is they needed more variation across different workload types. So this takes us to today. And we have over 400 different instance types for virtually any workload. And there's a variety of processors and architectures to choose from. We've invested in new capabilities over the last year, such as faster processors with more memory and more storage. Also, additional capabilities such as elastic block store for greater storage performance and greater flexibility, as well as elastic inference, which reduces the cost of deep learning workloads by up to 75%. And then last, also the Elastic Fabric Adapter, which is a network interface that supports applications that require high levels of internode communication. So as this all comes together, we're continually bringing new instances to market, and this will help virtually support about any workload and business need. In addition to all this, we're providing you a choice of multiple processors. If we think from the very beginning, back in 2006, Intel has been a long-time partner, and their processors have been essential for powering our most powerful instances. And if you look at Intel Xeon scalable processors, they're leveraged today across the largest breadth and global reach and availability across AWS geographies. In addition, for AMD, we launched back in 2018, and we're seeing strong adoption for their instance types. And last but not least, the AWS Graviton 2 processor, which is our very own processor. We launched it at reInvent last year, and this has really reignited the ARM ecosystem for server-based workloads. So we're already seeing customers test these various processors, and we're just excited to see what you can build. In addition to these fundamental architectures, more and more customers are using AI, ML, and HPC, and this requires purpose-built accelerators. For example, the AMD A100 Tensor Core and T4 Tensor Core GPUs, as well as the Xilinx FPGAs. There's also AWS Inferentia, which allow for 70% lower costs per inference compared to comparable generation GPU-based Amazon EC2 instances, as well as the AMD G4 AD instances and Habana-based Intel instances for additional workload types. So to dive deeper into AWS Graviton, so there are a variety of different instance types available. This is the second generation. And the second generation of Graviton-based instances offers up to 40% better price performance compared to current x86-based instances today. There are a variety of different types, as we mentioned. The M6Gs are suited for general purpose workloads. So think application servers, mid-sized data stores, microservices, gaming servers, and so on. For the T4Gs, they're suited for more burstable general purpose workloads. And until the end of the year, so December 31st, we'll offer the T4G micros up for free up to $750 a month. The C6Gs were launched in reInvent last year, and these offer basically additional compute performance, and it's best for compute-intensive workloads. So think high-performance computing and video encoding. And the C6GN variants also offer enhanced networking as well. For the R6Gs, those are built for memory-intensive workloads. So if you think about your open source databases or anywhere you need large amounts of perhaps scratch space. And then last but not least, we have the memory optimized instances. And those offer the lowest price per gig of RAM. For the M's, the C's, the R's, and the X's, we also offer SSD-based storage if you need perhaps a lot of local storage for power your applications. And then for those same instance types, you also offer bare metal options as well. So you have a variety of different types to choose from, and it offers you increased flexibility compared to the first generation Graviton instances. So now that we've covered the basics, and you're thinking, well, how do I basically select the right Amazon EC2 instance type for my workload? And the first thing I'll mention is it is a process. So selecting the right instance type is a process, but don't overthink it. First thing you want to do is familiarize yourself with the various categories of instance types. So do you need a general purpose instance? Do you need a burstable instance? Perhaps you need more storage. Perhaps you need enhanced networking. Do you need GPUs? So these are the things that you want to start to look at and get a basic understanding of these various instance types. But you don't need to memorize everything. Instead, what you want to do is focus on using Amazon EC2 efficiently. But don't try to completely optimize for cost on the first pass when you're doing instance type selection. Just focus on optimizing for your workload. And then what we'll do is after the second pass, we'll look at optimizing for cost via various purchase options and the cost optimization tools later. But you want to start with what are your application requirements, and you know it the best. But that being said, there's a good chance that multiple instance types are going to work for your workload. So you want to think flexible because the more flexibility you have, the more options you'll have in terms of optimizing for both compute and capacity. So some of the things you may want to think about are, what are my business requirements, right? So are you thinking about high performance? Do you have SLAs that you need to worry about? What are key bottlenecks you need to consider, right? So are you thinking disk I/O or memory I/O, network utilization? If they're multiple, then you need to start writing those down. But think about what are the ones that are the most core important ones for your business. Once you have these questions answered, you can start to move into deciding which EC2 instance types are the best for your workload. What you'll want to do is take an attribute-based approach for instance type selection, and then work backwards from your application and workload performance requirements. So there are a lot of attributes to choose from, and don't get scared by looking at this snapshot, but consider it a one-stop shop to really help you decide on the best instance type before going through the entire EC2 instance selection process. So once you understand what your application requirements are, then you can start to think about what processors I need to consider. Can I use AWS ARM64 instances? Do I need faster processors? Is it a gaming workload? Is it HPC? Maybe I need a high memory footprint because I need a lot of scratch space for my application. Or maybe I need enhanced networking if I have a lot of internode traffic. So these are all the things I want to be thinking about. And then from then, you can start to back into which instance types work the best. So you'll focus on the capabilities and options that are best required for your application and your workload from these. So what you may be thinking is, given all of these options, what kind of tools do we have to choose different instance types? And the Amazon EC2 Instance Discovery tool is something we launched last year to help customers optimize performance selection for a variety of planned workloads. And with this tool, what customers can do is they can leverage it as their single source of truth to find the latest instance types across availability zones and regions, and even make pricing comparisons across those. They can compare instances across hardware attributes, various pricing styles, and just seeing the availability of each instance type across these various options. So this is available both via the console and via programmatic access. And what it allows customers to do is build in automation to help their workload understand what is the current list of generation or the current list of instances that are available today. And it helps future-proof workloads in this case. So to sum it up, this is going to help customers lower costs and optimize their compute by always having the latest instances available to them. In addition, something that we recently launched is the attribute-based instance selection for auto-scaling groups, as well as EC2 Fleet. And this allows customers to express their requirements as a set of attributes. So this can be a set, so you can choose vCPU, memory, storage options, and several other things. And what this is doing is it's going to allow customers to create a list of instance types based off of these attributes. And it's ideal for flexible workloads. So consider perhaps containerized workloads, which perhaps per task, customers may not care about the exact underlying hardware that's underneath. And perhaps they just care about how many vCPU and how much memory that you need per task. Or big data where they may be instance type flexible, or even CI/CD workloads. What this is doing, this is future-proofing configurations by allowing customers to automatically leverage newer instance types because attribute-based instance type selection will come back with a list and select it this way. Also, the best way to run EC2 Spot is to spread your workload out across multiple instance types and sizes. And this gives customers the freedom to leverage Spot best practices in a way that's automated. So definitely if you're using EC2 Spot or containerized workloads or big data workloads or CI/CD, this is something that you're going to want to consider. So now that we have these options and tools covered, let's talk about how we can optimize cost, price, and capacity. So the first question I usually hear from customers is, how do we optimize cost versus performance? And as I'm keeping cost optimization in the back of mind across various workloads, do I need to sacrifice performance and availability? And traditionally, cost optimization is viewed as an either or in comparison to performance. But what if I told you that you could keep your performance requirements met and not sacrifice low cost? So is it a trade-off? The answer is no. And it's really a matter of understanding what your available pricing options are and leveraging the right tools to manage capacity and take advantage of that guidance to form best practices around. So there's three different vectors that we're going to attack here. And let's start with pricing. When we look at compute, there's really three major purchase options. And the first is on demand. And this allows customers to pay by the second with no long-term commitments. There's lots of flexibility here. As we mentioned before, there's 400 different instance types, over 400 different instance types to choose from. And this is where many customers start their journey. It's excellent for spiky workloads because there's no commitment required. And it's usually where customers start to build out a new application as they're beginning to define what their requirements are. And after on demand, customers usually begin to cost optimize in a couple of different ways. So the first are savings plans. And savings plans are great for steady state workloads. Um, what customers will do with savings plan is you're making either a 1 or 3 year commitment, and it comes with a significant discount off of on demand. Saving plans are also instance flexible, so you can leverage multiple instance sizes, you can leverage multiple instance families, really whatever works for your workload. And then there's spot instances. So Spot leverages the unused EC2 capacity. It also has the same pay-as-you-go pricing as on-demand instances, but can potentially come at up to 90% off of on-demand. Spot is best for stateless or fault-tolerant workloads, and we ask that customers be instance flexible when leveraging Spot, just because the more instance flexible you are, the greater chance you have of achieving and maintaining large amounts of Spot capacity. So for Spot and Savings Plan, we ask the customers to be flexible. Savings Plan allows you to be flexible, and the more instance types you allow it to leverage, even for on-demand instances, you're going to have more likely to get large amounts of capacity. And Spot asks the customers to be flexible, just because the more flexible you are for Spot, the better experience you'll have leveraging it. Both Spot and on-demand are mechanisms to launch capacity, with Savings Plan being a billing mechanism that applies to Savings Plan, to on-demand instances. So considering savings plans, there's two types. We have the Compute Savings Plan, which allows customers the greatest flexibility and up to 66% off of on-demand prices. For Compute Savings Plans, customers can be instance family flexible. So for example, you have the freedom to move between C5s and M5s, as well as region flexible. So considering perhaps you want to leverage a workload in multiple regions or you're going to move regions, you have the ability to do that. Also, the operating system, you can be operating system flexible, tenancy flexible, and you can leverage it across multiple compute options. So both EC2 and Fargate. For EC2 Instance Savings Plan, we look at a little bit deeper discount. So we say up to about 72% off. So very similar to standard RIs. And you don't have as much flexibility, but you can be flexible across instance sizes within the same family and type. So for example, moving from an M5 XL to an M5 4XL, as well as the operating system and tenancy. So you have two different options to cost optimize for steady state workloads in this case. And you can combine Savings Plan with on-demand capacity reservations. So these are also created for steady state workloads. On-demand capacity reservations enable you to reserve compute capacity for your Amazon EC2 instances for a specific availability zone for any duration. You have the ability to create and manage capacity reservations independently from the billing discounts of savings plans or regional reserved instances. There's no commitment required, and you can tailor make this to a particular AZ or share across various accounts. Keep in mind that on-demand capacity reservations are active whether or not you run instances. So with that being said, they are best used in tandem with Savings Plan, just because they both benefit steady state workloads. And typically we see customers, if they're leveraging Savings Plan or they're leveraging on-demand capacity reservations, they're using one with the other. And next we have EC2 Spot instances. So when we consider on-demand, AWS EC2 operates at such a breadth and scale that a wide majority of that capacity goes unused at any particular point in time. And that unused capacity is sold on the spot market. Because of that, spot instances leverage the exact same capacity as on-demand. and use a lot of the same API calls, although a few are different. For pricing, spot instances changed in 2017. And pre-2017, there was a notion called bidding, which doesn't exist anymore. Nowadays, instead of a bid price, customers just set the maximum price they want to pay, and the bid price was replaced with a spot market price. That market price changes infrequently, and it's based on long-term supply and demand of those particular spot instances. Once bidding was removed, today, now pricing changes. It's very smooth, it's infrequent, and frankly, it's very predictable. So we encourage customers when leveraging Spot to be instance flexible. And this means is leveraging Spot across different instance types, sizes, and availability zones, and ideally leveraging an Amazon EC2 auto scaling group, because this makes it much easier to leverage Spot best practices, in this case, instance flexibility. In addition to all of these notions, you're thinking, okay, well, I don't have to make a commitment, and I get a very aggressive discount. Are there any nuances I need to be aware of? And the thing with Spot is AWS can reclaim Spot instances for on-demand when on-demand needs that capacity back. When EC2 needs to reclaim that capacity, we call it a spot interruption. But before that capacity is reclaimed, we give customers a 2-minute notification called the spot interruption notification. So with that being said, there are lots of ways to automate a response to this, and we'll talk about that a little more in a minute. But Spot is integrated within many AWS services, as well as partner offerings and open source software. So one of the things you should know is that when it comes to building Spot best practices, many of those are actually built for customers for common use cases and tools. So let's talk a little bit more about spot interruptions. Spot interruptions actually occur very infrequently, and less than 5% of spot instances have been interrupted in the last 3 months. What this means is that over 95% of these instances were terminated because perhaps the customer was done with their work and they gracefully terminated that instance. Or perhaps the auto scaling group saw that those instances were underutilized and had a scale-in event. Either way, what we're saying is that interruptions happen infrequently, but you want to be well architected and you want to prepare for the event that it does occur. So if you're going to plan for interruptions in case they occur, you want to understand what happens when they do. And when an interruption notification happens, it lands in 2 places. The first place it lands in is Amazon EventBridge. The second place is the instance metadata of the spot instance being interrupted. What we're expecting customers to do is take that spot interruption notification and automate a response to that. And that response is going to depend on the workload or that application. For example, let's say you have an HPC application and you see a spot interruption notification. You can automate a response to checkpoint that work. So you can save that work, and that way you can resume once spot capacity is available again, or once it's replenished by the auto scaling group. Or imagine you have a web front end that's leveraging Spot. You can have that notification trigger draining from your Elastic load balancer, or even for a containerized application. You can also trigger different spot interruption reactions. You can start or stop that instance or hibernate it to allow for restarting those instances faster once the capacity is available again. The other good thing is for common spot use cases, interruption handlers have already been built. And for example, let's look at Amazon ECS and EKS because those are very common uses for Spot. Spot is integrated very tightly with an Elastic Kubernetes service and Elastic Container Service. And what we mean by this is that spot interruption handling is already taken care of for you. And if you're leveraging either of those 2 services, if there's a spot interruption notification, those services will automatically find the notification and begin to do container draining from those nodes. So what this is going to do is basically save you the undifferentiated heavy lifting of running containerized services on EC2 Spot, and frankly reduces the time to value for our customers. In addition to the spot interruption notification, there's also a second signal that's available now, and we call that the rebalance recommendation signal. So the rebalance recommendation signal notifies customers when a spot instance is at an elevated risk of interruption. And because of that, this can potentially arrive sooner than the 2-minute spot instance termination notice. So the purpose of this is to help customers proactively rebalance that workload to new spot instances that aren't at an elevated risk of interruption. And this is helpful if your application can leverage more than 2-minute notification as a response. And an example is maybe you want to start checkpointing your work early to save as much of the state as possible. Or perhaps you want to avoid scheduling new jobs on instances that are at an elevated risk of interruption. This increases the chance of actually completing your work. So the rebalance recommendation for spot instances is also integrated within auto scaling groups. We'll talk about a little bit more in the moment. But effectively what's going to happen is if you enable auto scaling group support for rebalance recommendations, the auto scaling group will interpret that recommendation and it will actually begin to spin up a new instance before the old one is taken down. And what that does is that actually increases the chance of you maintaining your desired capacity. In addition to that, it's going to wait until the new instance passes health checks, and then it will go through all the lifecycle hooks for tearing down the old instance and spinning up the new one before the old instance is removed from your fleet. So there are more options today to mitigate any chance of interruptions, as well as prepare in case interruptions occur. And you have more flexibility now across what kinds of workloads can leverage Spot. So a common question I get from customers after implementing Spot best practices of instance flexibility and automated interruption handling are, well, what's the optimal location to run my Spot workload? And what will my experience be like once it's running? Historically, to answer this, customers required to spend significant time and sometimes cost testing various configurations across several regions just to understand what that experience is going to be like before they can even deploy that workload into production. And so to shorten this time to value, we recently relaunched a new feature called the Spot Placement Score. Now, the Spot Placement Score, it helps customers select the optimal regions and availability zones for a particular spot configuration and desired capacity. What customers will do is they'll input a list of instance types that work for their workload, or they can leverage attribute-based instance type selection. And basically what that means is you can define how many vCPUs your workload needs, how much memory your workload needs, and behind the scenes, we'll build a list of instances for you for that particular configuration, and we'll output a list of regions and or availability zones that have been selected for that particular workload. This would come in the form of a set of scores from 1 to 10, with the higher number being the better chance that that workload will launch in that region, in those availability zones, given your configuration. So it's a point-in-time score, and it's basically there to reduce the time to value of customers launching new Spot workloads, or even just looking for additional regions to run their existing Spot workloads. So we're really excited about this feature. I think it's something that customers have been asking for a very long time, and we're happy to bring it to bear. So as cloud environments and usage scale, optimizing these costs correctly become very essential. And one of the questions I often get from customers is, okay, well, do I use on demand? Do I use Spot? Where do I leverage savings plan? And is it an either or purchase option? And really, in many cases, you may want to blend multiple options together. For example, for databases which are steady state and persist data, typically customers will want to leverage savings plan to cover those. On the other hand, for a stateless web application, customers can mix Savings Plan with Spot, leveraging Savings Plan to cover the base of that workload. Perhaps there's a level of compute where customers want to keep available at all times, and then leverage Spot as that application leverages elasticity and begins to scale out and scale in based on customer needs. And for job processing, perhaps it's a workload that runs intermittently, perhaps once a week or once a month. There's many customers that leverage 100% Spot for these. But depending on your workload type, there's various mixes, and it's ultimately going to depend on what are the requirements of that workload. Is it instance flexible? Is it fault tolerant? Does it need to run steady state? And that will dictate which purchase option or combination of purchase options are the best to choose. So second, let's talk about capacity. So one of the best tools to leverage and maintain capacity is EC2 autoscaling, because autoscaling allows customers to mix multiple instance types and purchase options, ultimately reducing the cost of the entire workload. So customers have the freedom to mix Spot, On Demand, and even Savings Plan within the same auto-scaling group. And with Spot, if customers are willing to be instance flexible, the auto-scaling group can be configured in a manner such that it will actually look across all of the instance types that work for a customer's workload and find the instance types that are the least likely to be interrupted by finding the deepest capacity pools and considering historical information. And through this, it actually reduces the chances of Spot interruptions. For on-demand instances, auto-scaling can consider multiple instance types and leverage a prioritized list. So if you give it multiple choices, it will actually choose the first instances in that list. And then if that isn't available, it'll go to the second and then the third. Auto-scaling also maintains application availability. And if an instance becomes unhealthy for any reason, or if there's a Spot interruption, the auto-scaling group will replenish that capacity. So auto-scaling is a mechanism to reduce costs, optimize performance, and eliminate operational overhead. To dive deeper in auto-scaling, there's multiple configurable options. The first is, we want to set what percentage of instances are going to run on Spot and what's going to run on demand. And the mixed instances policy is the place to actually add those configurable items. So that's going to allow auto-scaling to provision a combination of Spot and on demand as the auto-scaling group grows and shrinks. And I can also set a baseline of minimum on-demand instances I want to provision. And as I mentioned before, I can cover those with a savings plan if that's the intention is to be steady state. I also want to give my auto-scaling group a list of instances to choose from. And the more flexible, the better. And for Spot in particular, the best thing I can do is be flexible across, ideally, I want to be able to be flexible across instance sizes, types. So I may want to consider Cs, Ms, different families, different generations perhaps. I can choose C5s, C4s. And I can even consider oversizing my instances because typically if you give an application more memory and CPU, it won't break that application. So consider as many different options as you can, in addition to multiple availability zones. And these are your keys to success. And as we mentioned before, there's also a base capacity I can set on demand to be covered by savings plan. And the last but not least, I'll also want to configure a Spot allocation strategy. In this case, we're leveraging capacity optimize, which will find the deepest pools for customers. And we'll talk more about this in a moment. And if I want to enable capacity rebalance, as we talked about before, I can configure this here. For the capacity optimized Spot allocation strategy, this is my mechanism to reduce interruptions by being instance flexible. So if I can see here, I set a desired capacity. I choose my multiple instance types, and in the example in the slide, I have R5 larges, M4 larges, and M5 larges to choose from. And across my availability zones, the spot allocation strategy capacity optimize is going to choose the instances that are least likely to be interrupted by looking at real-time capacity data. And for US East 1A, if we look, the bar chart represents available capacity, with R5 larges having the deepest capacity and M5 larges having the lowest capacity. And for US East 1A, we'll choose, or the spot capacity chosen will be the R5. For US East 1B, the M4 would be chosen. And then for 1C, the M5 will be chosen. So the goal here is to reduce spot interruptions by choosing capacity from the deepest pools. And this is what Capacity Optimize is built for. And we expect most customers to use for most workloads. So the good thing here is that Spot is integrated with many AWS services, as well as partner offerings. And the whole purpose of this is to reduce the undifferentiated heavy lifting for customers to build Spot into common use cases. We covered auto scaling groups, but also containerized workloads, so Amazon ECS and EKS, as well as Fargate. AWS batch jobs are also excellent use cases for Spot. There's a strong integration story there, as well as for Amazon SageMaker. Allows customers to reduce the cost of SageMaker training by leveraging Spot instances. Big data workloads leveraging Amazon EMR are also excellent use cases for Spot. And Spot is very strongly interwoven into the EMR product. And customers can also leverage CloudFormation to deploy Spot instances as well. And beyond that, there's a variety of third-party partners and independent software vendors that can also leverage Spot through their integrations, and through that, basically handle a lot of the interruption handling and just reduce the time to value for our customers. So the last vector to optimize across is performance. So we'll look at how to enable AWS resource recommendations to really reduce not just the cost, but improve performance as well. A key service here to improve performance is the AWS Compute Optimizer. The Compute Optimizer recommends optimal instances across AWS Lambda, as well as EC2 and EC2 auto scaling groups, across many different instance types, including the M's, the C's, the R, T, and X families. And this actually lowers the cost, improves workload performance. The Compute Optimizer leverages machine learning models trained across millions of workloads, and is looking at different items such as resource utilization, the configuration and performance data of a workload, and helps customers optimize these resources. The Compute Optimizer helps customers choose optimal configurations across EC2 instances, EBS volumes, Lambda functions, based on utilization data. And it'll infer how a workload would have performed across various hardware configurations to help customers select the best. The Compute Optimizer delivers up to 3 recommended options for each AWS resource analyzed. So there's several customers that are leveraging all of these compute tools. And if you look at Applica, Applica leverages a workload that scales elastically. And their platform needs to handle between 5 and 50 posts per second. They leverage auto scaling to achieve this. And through that, they're able to scale their infrastructure up to 10 times without any issues. And as a result, they only pay for what they use. And that drastically reduces the cost for them. Fred Hutch leverages EC2 Spot instances for their microbiome research. And through Spot, they save less money and leverage, and takes less time to get scientific answers. And Fred Hutch is leveraging Spot and auto scaling to fight cancer. And Nubank leverages Compute Optimizer as their single pane of glass to help make cost optimization and performance optimization recommendations. So this is a small set of customers out of the many that are leveraging these different tools to be successful and optimize across compute and capacity and price. So what are our takeaways here? The first is we want to familiarize ourselves with the various instance type categories, but don't stress over it. You want to take an attribute-based approach to instance selection and leverage instance selection tools such as the EC2 Instance Discovery, as well as attribute-based instance selection. And then last, we're going to leverage all of these tools and options to optimize across price, capacity, and performance by choosing the right purchase options for the right workload. And this could be savings plan, on demand, spot, or a mix of any of those three.